OK 我们再开始上课。好，let's get back to work. It looks like I made a mistake, so I might have lost the video of the previous hour. Let me make sure that okay, recording is done. Okay, so we cover another important function in R, right? It's called error apply, right? The idea is when you want to do iteration, you basically put you basically put the data in an iterative, or sometimes we call collective object, right? Just like you put the data frame inside a list, okay? So and then you can apply a function, a built-in standard function, or a self-defined function to each element of that list, of that collective object, right? In this way, you can do repeated operation, right? You don't have to do it like 5 times, right? You just apply the function to the list, and then that function would apply to each element of the list, okay? This is also a very important thing. That's iteration, repetition. Okay. Now, so with that, it's easy to like answer the summary statistics, right? They want to see the number of observation, right? So you no longer need to use R and number of row to each of the data frame, right? You simply apply number of row to L, right? And then you can see that every one of this data frame has 480 observations, okay? And then the earliest year in your data set, right? So that's what we want to do, right? Okay, we can do the minimum on the date, right? And convert the date into character. And this is what we want to do, right? The function is like this. Actually, I can write in this way. It should be clear. It should be more easier to read. When you define function, you can put the function into this basket, right? So everything inside this basket is the function, okay? So see, now we for each of this data frame, we pick out the minimum date and transfer it into character. You can see that, right? So you can see that. That's the year in our data set. So we want to see basically the same thing, right? Just use maximum. Okay? Then of course you can do that 5 times, right? If you actually keep the 5 data frame in 5 different objects, you have to do the same thing like 5 times. Now you don't need to do that, right? Now you want to see the mean stock price, right, of IBM. Now because IBM is inside L, right? So if you want to see the IBM data frame, you can use this expression, right? You can use the arrow and dollar sign and see arrow, and right, it's kind of like it's kind of like indexing into a list. It's pretty much the same as like indexing into a data frame, right? Okay. It's because each element has a name, so you can like index each of the sub-element of L with each name. And then you want to see the stock price, right? this is the data frame. Now I want to see this column of the data frame, right? Isn't it? Okay. So this is the stock price of IBM, and you want to take the mean. Okay. Now minimum stock price, basically the same, right? You write this way, right? Because the G is inside of L, so you have to do this, right? Well, this question are basically the same, right? They're asking about the median, asking about the standard deviation, right? And these are the built-in R functions, so it's not too difficult. Now, so you're asking about clock, right? What is the year of the highest stock price and what's the time of the lowest stock price, right? So actually, if we want to see the stock price, we can do this, right? We do a plot, right? We use Cox date as the X. We use Cox stock price as the Y, right? Okay. And because the day is already been transferred into a day type, so it is linear, right? So we can use this numeric linear number as the x-axis. So we can see that the highest stock price is here and the lowest stock price is here, right? Okay, still difficult to read, isn't it, right? So you can add some line on it. Sorry. This function add line is actually to add some assisting line, right? To add some assisting line. So look at here. I'm doing a which max as the index, right? Which means that I'm indexing the point of highest price, and here I'm indexing the point of the lowest price, right? So with these two things, I want to see the date because I want to draw a line in the position, isn't it? Okay, so it's like 1973 and 1980, right? That's the way we do it on the plot. Okay, you get the point? Okay, so actually this question can be do without plot. You can actually do this, right? Because you want to see the day of the maximum stock price and the day of the minimum stock price. So you can actually see the, right? You can actually see the date, right? And here I just want to show you that you can actually, uh, using this appline function, you can draw these two locations at a two vertical line, right? V means vertical line, it's a color, right? So uh, so when you have this two date, and I want to draw this two date as two vertical line, using this f-line function, right? In green and red color, okay? Now there are three uh, consecutive question asking about the. It say that in the March of 2000, uh, technology bubble burst, right? Uh, have you born yet? I mean, at the time of bubble burst, have you born yet? I mean, what is your age? Have you over 20 years old? If not, you have not experienced this. This is actually a terrible thing, right? Okay. Uh, a lot of people get out of job. And then there's another time, right? 1983. Right? The, so see, they're asking for like if you draw the line and you want to you want to draw a specific time, right? So you can like you need to use add line to mark the time so you can see it. So you can see it. Um, kind of like I may need to reload this notebook again. Sorry. Which one is that? So if you want to answer a question like this, right? Um, you have you need to draw the stock price, and you will have to like right. You have to draw some assisting line. Otherwise, you cannot. So this assisting line is actually the date. Let me go here. So uh, it's asking about the stock price of Coke and P&G, right? And so the stock price of Coke is in blue, and P&G is in green color. And well, in addition to their stock price, we will also need to mark these 2 days, right? The March of 2000 and also the 1983, isn't it? Right? So after you draw in this assisting line, you can actually answer the question very easily. It say that which company's stock price drop more, right? So it's like in here, right? You can tell that at bubble burst, P&G stock price drop a lot, but Coke is not that severe, isn't it? And then during 1983, it's actually this assisting line, right? It's the same thing, right? When in 1983, actually the stock price of P&G dropped a lot, right? Not Coca-Cola. Now it's also asking in the show the plot which stock generally have lower price. Generally have lower price actually Coke, right? For most of the time the P&G stock price like higher than Coke, right? Isn't it? So to answer this type of question, you actually need to draw the line, and you actually need to mark the time, right? Then so you can answer the question. If I just give you the numbers, you can never answer this type of question, right? Okay. So in this exercise, we are exercising how to draw lines, right? And how to draw multiple lines. Right? The first line can be drawn with plot, right? You simply use the here is the x axis, here is the y axis, right? You need to see you need to use type equal to L for time plot, right? Then you specify number, specify color, right? So you can distinguish between series, right? Now, starting from the second line, you no longer use plot. If you use plot, you will plot another plot, right? So you don't want to plot another plot. You want to plot a line on the existing plot. Then you use this line function code. Okay. Uh, if you use plot, it will actually generate a new plot, right? But you don't want to do that, right? You want to add a line on the existing plot. You want to draw two assisting lines on the existing plot. That's where you use the line function and applying function. The legend is just to add this box, okay? Just to add this box. In the top right, I just add a legend, right? Okay, and the argument is kind of like self-explanatory. And now this is actually the same thing, right? It's just like, but you only want to see that 1995 to 2005. So we will have to shorten, right? By using indexing, shorten the period. So, and you also need to like draw in this assistant line before you can actually answer the question. Okay. So, so actually, I already which stock reached the highest value in the period, right? So you need to see it, right? So I should have put a legend here. It's not easy to see it without a legend. So so the one who reached the highest value is actually IBM, right? And it's in green color. And so it's asking about 1997, 1998 period. It's this period, right? You want to see that which company saw a decreasing trend in their stock price, right? So you can see that in this period, see the blue line is dropping, and 1997, so it's here, right? So some stock actually are rising, right? So only two stock are falling. It's actually the blue one and actually the orange one, right? So the blue one is like P&G, and the orange is the Boeing, right? So the answer is P&G and Boeing, right? And it's the same thing to answer this question, right? So in order to answer these questions, you basically need to draw a multiple line plot and then you need to add in the assisting line, then look into the line, look into the plot to answer the question. Now, the last thing in this notebook is about monthly trend, right? Monthly trend. So now, the question is actually a little bit complicated. You want to compare the monthly average to the overall average. Let me say it again. You want to compare the monthly average to the overall average. To see the overall average, you do it this way, right? Right. You want to do a mean on the entire data frame, right, of IBM. So this is the overall stock price, right? Now, if you want to see the monthly average, then you want to do the average of stock price by months, isn't it? We have done this already, right? So this expression would actually generate a monthly average stock price, right? So we generate the monthly average and we minus it with the overall average. So whatever is positive, it is above average. The month is above the overall, and then whatever is negative, that month is below the average, right? So as you can see that IBM, this stock, they in the first 5 months of every year, they tend to have a higher stock price, right? And for the rest of the months, this stock tend to have a lower stock price, right? Okay. So the point is to do a monthly average in this way and do a overall average in this way. Now, GE and COG. Now, this is another way that you can use as applied, right? So see, in this as apply, I actually do a T apply, right? So to answer this question, I actually use two apply function. Now, in this T apply, it actually, we do it a lot of time already, right? In this T apply, I actually do a average stock price for every month, isn't it? Right? This T apply, I calculate the monthly average price of DF, right? But what is DF? Because we are doing S apply on L, so actually this function will apply to all of the 5 stocks, right? So in this command, in these 3 lines of code, I actually generate the monthly average for every stock, right? Now you see the power of iteration, right? Okay. Because I want to do a monthly average for IBM, GE, P&G, Koch, and Boeing, right? So I basically define a function to calculate the monthly average, and then I apply it to every element of the list, right? Now I get a matrix, right? So I can answer the question like, right? Which month has the highest average price? You get it, right? So and actually, it's also easier to answer this question. It is asking that they want to compare the stock price of December and January, and in general, there's a month, right? December or January, there's a month that average stock price always higher. So you can see that if you compare this to this, right? It's, which one is higher? January is higher, right? Okay. If you compare corp, so which one is higher? January is higher. P&G, same thing, right? Just average price of January is higher than December. The same thing happened in GE. Same thing happened in IBM. You see that, right? So if you want to buy stock, you buy it in December and sell it in January, then most of the time you will earn money, right? Okay. So this is the for section 4. You no longer need to use plot, but you will use, if you can use lapply, it would a lot easier. Think it this way: if you do not put the stock price in the list, now when you want to do this, you will have to type it 5 times, right? Okay, and the phi vector will be printed separately, right? So when you want to do a comparison, it will be very difficult, isn't it? Okay. Not only that you will need to type phi command and see phi answer. If you want to do comparison between these 5 vectors, actually quite difficult, right? But now with this sapply, lapply function, you can actually apply a same function to calculate the monthly average of each of the sub-element in the list and then put the answer together. So it's much, much, much easier to answer this question in this way, right? Now this is for the second second notebook. Okay. Now we have like 20 minutes like to do the third one. So I think I'll just like I'll try to explain the third one in the web page because we kind of run out of time, right? So here again, there are a few things that we want to learn. The first thing is the concept of NA, which means the data is not available or not applicable, right? So you have missing data. If you're doing census, you will have a lot of missing data, right? And so there are some troublesome effect of NA. We will see it and we will learn how to handle it, right? And we'll also learn how to merging data frame, right? In this example, we actually have 3 different data frames. We have census data, right? So this is the column. This is the variable of the census data. And in the census data frame, there's a column called metro area code. This is actually a code. It do not have a name, right? And it has a country of birth code. Actually, again, this is the code. It do not have a country name, right? So in order to acquire the country name, you need to do a kind of like a table lookup, right? We have 2 other let me do it. Besides the census data frame, right? We have two more data frames. One of the data frame is the mapping the country code into a country name, right? It's called country, and the other one is metro. It's mapping the metro code into a metro area name, right? So that's the. So you need to do some table lookup, right? To answer some of the question, you need to do some table merging or table lookup type of things, right? And when you do table merging, when you do table lookup, sometimes you cannot look up. Sometimes some element will be missing, right? Okay, so that is another reason that you might generate some. And when you do merging, if you look up the table, sometimes the key is not there, right? So when you do the lookup, you will produce NA. It's a reason to produce NA. So in this notebook, we kind of like to learn two things: the merging table and also the handling of missing data. Right, it's two things. This is easier, right? I just read in the data and then summarize the data. Now, if I want to see which column has the missing data, the easiest way is to do it this way, right? So there's a function called is NA, and I put the data frame in this function code, and I do a column sum. So I can see that for each element, how many NA do I have? Do we have? So you can see that we have NA in metro area code, right? We have NA in education. We have this many NA in industrial. We have this many NA in employment status. Okay, and for the rest of the columns, we do not have NA. We have NA in these columns. Now again, this is a simple question. I don't do it now. Now, now it is asking that among the interview with the value report of see, because this industry column has a lot of NA, right? So in this question, it is asking about what is the most common industry of employment among the interviewees with the value reported in industry, right? So actually, we can simply just do a table, right? Let me do it this way. Actually, this answer can be this question can be answered simply in this one line of code. Okay. Because if they are NA, the table will not count NA, right? By default, you're using table on industry, right? If table will not count NA by default, right? So to answer this question, you simply do a table and do a sort. So the most common industry is just like education and health, right? Okay. If you do want to see NA, you have to do this, right? If for some reason you want to also count NA in the table, you need to add use NA equal to if any. So if any NA will also be count, okay? So let's see. You see that a lot of people are NA, right? And out of excluding these NA people, the most common employment industry is actually education and health. All right? Okay. Okay. So use table, you don't need to worry about NA. But if for some reason you want to count the NA, you need to use this argument. Okay. Now, which state has the fewest interviewee? It's simple, right? Just do it. You want to see the fewest, so you want to see the head, right? Okay, because it's if I don't do this, it will be a very long list, isn't it? It will be a very long list. How can you see it, right? And if I do not do sort, how can I look into the number to sort for me? So I do sort, and I see the head. Now, because it's in ascending order, right? So sort head. It's, you will use a lot when doing this set of assignment, right? The same thing, large number of interviewees. Now you use tail, right? Because it's ascending, so the largest is on the tail. Now, what proportion of interviewee are citizens of the United States? If you do a table of you actually see that the citizenship variable actually have 3 different values, right? So, so the citizen of the United States actually has 2 different values, right? They can have citizen native and citizen naturalized, right? So, well, you have to do it 2 ways, right? You can do it in table and add these 2 things, right? An easier way is actually just exclude the non-citizen, right? So the easier way is to they want to ask the proportion, right? Okay, so the correct answer is this way, right? You exclude the non-citizen, and then do the mean, right? Okay. I should say test for non-citizen and do the mean, right? And then which race has at least 250 interviewee in Hispanic ethnicity. Actually, here there's a variable called Hispanic, okay? And as you can see that it's in 0 and 1, right? If that interviewee is Hispanic, it would be 1. Otherwise, it's 0. Okay, so this is easy, right? We simply do a sum by race, right? See, I want to count the number of Hispanic by race, right? Again, it's T apply, and then you sort it to find the to see that. So this is the number of Hispanic in each race. Now he's asking for which race has at least 250. So this 4 race, right? American Indian, multiracial black, and also white, right? So now he's asking for which variable has at least one interviewee with a missing data value. So I told you already, right? We just use this. Uh, which variable? Say, let's metro area code, marriage, employment status, education, industry, metro, right? Okay. Country code also. And wait a second, I think I should do this. Some of the fields actually add in later on, right? So when you run to this point, you should only have 1, 2, 3, 4, 5 variable has at least one employee. Which of the statement below is the most accurate? It, Actually, the point of this set of questions is to asking about uh, which variable is has a has a strong has the strongest relationship with the missing value in marriage. Okay, so it's you want to see that whether there's a rule between age and the NA is married. As you can see that if I do a table, right? So you can see that this is age, right? And this is the number of NA, right? Sorry, this is the number of NA. So for all of the for all of the interviewees that below 14, before the age of 14, they are ONA, right? As you can see that, right? So this type of NA is not random, right? This is what we call by systematic NA, right? So we are looking for a systematic NA across this variable, and we find one, right? There's only one variable that has a clear rule to the NA of marriage, because if you are if your age is like under 15, it's not likely that you can you're married, right? So and you can see right a sharp distinction, right, uh, below and beyond the age of 15, right? So as I see here, that NA this type of NA is not random. This is the systematic NA. Now, now see, in the data set, there's a variable called metro area code, right? So if the interviewee is not living in the metro area, then this field will be NA, right? You must live in the metro area, so you have a metro area code, right? So this type of NA is not random, right? It actually carry information. I should say that, right? So NA does not mean that there's no information. Sometimes NA has a meaning. Yeah. In this case, that NA means this interviewee is not living in the metro area. So this is the way to do it, right? I want to count the. I use is NA metro area code. I do the mean. In this way, I count the interviewee, the ratio that living in the metro area, right, by state. Okay, so let me say it again. uh, in this expression, I like draw out the NA status, right? And I do a mean. So this is basically the ratio of the interviewee that not living in the metro area. And I want to calculate this ratio by state, right? Okay. So, so as you can see that in Alaska and in Wyoming, right, all of the interviewee are not in the metro area because I don't think that they are metro area in Alaska, right? uh, and Wyoming is also a very cold state actually. So so this type of NA they actually carry information, right? They actually carry information. Now, and this is basically the same, about the same thing, right? Okay. Uh, we need to run faster. Let me see. We are here already, and we may need to do some explanation about this one. Okay. Which state has the proportion of interviewee living in non-metro area that closest to 30s? So after I after I obtain the ratio of NA in metro area, after I acquire the ratio of metro, I need to calculate its difference between 30%, right? And then the difference could be positive, could be negative, right? So I need to do this is an absolute value, right? So I calculate the ratio, I minus it with 30%, and I apply a absolute value, right? Then I sort it, I do a hat. Then so which one is closer to 30%? It's Wisconsin, right? It's almost 30% sharp, isn't it, right? So now we are running out of time already. So instead of like doing this in hurry, let me do it this way. Um, mm, let's take a quick ad of the assignment this week, okay? And then the red thing that I did not explain, I will make a YouTube video, right? So you can see it like later on, okay? It'll be like 10, 15 minutes. I just don't want to hold you up, okay? Uh, so this week's assignment is like this. I would like you to like finish the assignment, right? There's 3 assignment. I want you to finish them and then like uh, pass the answer. Uh, I mean, need the notebook and like upload it to a place, okay? And so finish the assignment if you have not. And then there is a personal assignment. I would like you to take this data chem course, okay? Okay, take this data chem course, right? You might not be able to follow everything the teachers say, but next week I would I will give you more explanation about this data manipulation uh, package. Okay, okay. So 2 things, right? Do data chem and also do the uh, assignment notebook. Okay. So after the class, I'll do two things this afternoon. First of all, I will like for the portion that I have not finished, I will make another video for you, right? Okay. And because like I I did not record the second hour of the class, I will give you the answer, right? I will give you the answer of the second notebook, right? Because I uh, missed the second hour video recording. Okay. Okay, that's for this week. So for anyone who have question, you can stay in the class, and for the rest who do not have question, we have the class dismissed. I'll see you next week. Okay.